You've got 15 engineers, you give them a CFD model, you're going to get 15 different answers. And so like, how do you standardize that workflow and make sure everyone's doing the same thing? And how do you catch errors before they happen or find them when they've been made? And all these kind of problems we as CFD engineers face all the time. Bramble really was our answer to that. It was like, how are we going to be better at what we do? And we developed it for our own consultancy, for our own business. And eventually we're like, this helps us, it helps us loads, maybe it can help other people.
Today I have the pleasure of interviewing Ivar Anitz, Managing Director of Bramble CFD. Thank you to Bramble for sponsoring this episode. Ivar has 20 years of CFD experience in aerodynamics, especially in race and road cars. He led the development of the Bramble CFD platform, which is used to automate and streamline workflow processes. I hope you enjoy our conversation, and please like, subscribe, and hit the bell. Thank you so much, Ivar, for joining the show today. I'm really glad to have you on.
Hi there. Yeah, good to be here.
Awesome. Can you take 1 to 2 minutes and introduce yourself to our audience, your background, early career, and where you're at now?
So I'm Ivar Anitz. I manage Bramble CFD, and this is a milestone year for me. It's 20 years since I graduated university and started doing CFD. So I've been doing it a long time. Started working at British American Racing, which are Formula One, working in their CFD department. And then in 2007, a few of us left and set up Totalson. I was the most junior at the time. But so I've been doing that ever since. And over the years, moved a bit into programming, and then ended up working on Bramble and ended up running it.
Awesome. I'm excited to dive more into that. So congratulations on 20 years as well. That's really exciting.
Feel old.
Well, that's not the intent. It's wisdom, right? Wisdom you've acquired.
Yeah, indeed.
So what was your first experience with simulation, though? Can you dive into that a little bit?
Yeah, so before I even went to university, I took a year out and did an industrial placement working at British Energy, who at the time, they managed or ran all the nuclear power plants in the UK.
Okay.
And I was placed in the simulation team. They developed an in-house finite element analysis flow solver, which got to use that and modeling very basic 2D flows in and around nuclear reactor plants. And really enjoyed it. So when I went off to university, I was doing aerospace engineering. And so I took the opportunity to specialize into CFD, and never looked back, really.
That's awesome. You had that opportunity even before uni. So one of the things that you talk about is, well, I guess let's back up. Where did the idea for Bramble come from? Like, how did this come about? You said you started F1, then you guys started Total Sim, but how did Bramble come into that throughout?
Yeah, it really comes from our own needs. It's been described to me as if you gave a bunch of CFD engineers the kind of time and resource to develop the software they want, the kind of Bramble's the output. And it really is that. It's, I guess early 2010s, the company had grown to like 15 CFD engineers, something like that. We had 1,000 cores compute or more, and we're doing a lot of CFD, and that produces all sorts of challenges. We generate loads of data, spreadsheets, PowerPoint, images, movies, all that kind of stuff. It's like, how are we going to manage all this data? And you've got 15 engineers, you give them a CFD model, you're going to get 15 different answers. And so like, how do you standardize that workflow and make sure everyone's doing the same thing? And how do you catch errors before they happen or find them when they've been made? And all these kind of problems we as CFD engineers face all the time. Bramble really was our answer to that. It was like, how are we going to be better at what we do? And we developed it for our own consultancy, for our own business. And eventually we're like, this helps us, it helps us loads. Maybe it can help other people. And we then opened it up for other people to use. I guess originally aimed at what would be larger CFD departments, but actually it does a lot of things that help people who know nothing about CFD do their own CFD. So it really came from us trying to want to do everything that we do, but better and faster and things like that.
Yeah. So can you give us an overview of what features Bramble has that allows you to improve your workflow, like all those things, but maybe diving into the features now. Okay, so what functionality does it have? How does it do that?
Yeah, we lean heavily into automation. So trying to effectively make the CFD bit of an engineer's day the smallest possible. The the real value in CFD comes from the learning, right? So looking at the data, understanding what your design changes have done. And so the more time we can get people doing that, so the more value you're going to get from your CFD. And so we try and make it as easy as possible for people to run simulations and make it easy as possible to look at the results and see the data. And so we look at the whole CFD process. Where can we get the computers to do it? Where can we catch errors and things like that? So we do a lot of automotive, motorsport type stuff. And a real painful thing to do is to change the ride height of a vehicle. So if you want to run increased ground clearance from a vehicle and things like that, you have to move the wheels, adjust all the suspension. You've got to recalculate rotation centers and ground axes and all this kind of stuff. But so we get the computer to do that. So the user just says, I want to run this car at 2050 ride height. Bramble will move the wheels and suspension. So we've taken that to an extreme where you can start with a half car. A Bramble will turn that into a full car model. Your 2 cars going around a corner to reflect the geometry, move the wheels, offset 2 cars and set it all up. So we take it to a real extreme so you can generate lots of simulations quickly and easy with minimal input. And then the back end is how can we make it easier for people to look at the results. And so we have all those automated post-processing. So we generate images and movies and things like that. So you run the simulation overnight and you can just come in the morning, all that data's there ready for you to look at and make your next design change and things like that. So make the CFD as small as possible and get on with doing the aerodynamics is what we like to do.
One of the things that you mentioned as I was going through the webpage, learning about Bramble, preparing for this, is that you used to use a commercial software. I believe it was Fluent, right? And then you were running OpenFOAM concurrently for a while, testing, okay, how does it match up? How does it line up? 2 questions here, though. What did you learn as you adopted OpenFOAM or open source? And then can you walk us through what you felt like needed to happen before you could justify completely switching to OpenFOAM?
Yeah, I think you learn one from it is that I think it's harder to get engineers to change CFD code than it is to get them to change religion. People get really wedded to their process and how they do things, and we were exactly the same. We used to learn, we trusted it. It's a good piece but for us, we got heavily into optimization, and that needs lots of simulations. And we didn't have the budget really to buy the commercial licenses to do it. So that was really our driver. We actually were developing our own CFD code at the time, but then OpenFOAM came along and we started looking into that. It's like, this could be really good. So building up that trust and convincing people to change is a real big part of it. Now, what we did was actually, we created 2 parallel queues effectively. So every time we submitted a Fluent job to run, automatically it would go away and create the OpenFOAM equivalent and then run the OpenFOAM case. So over the course of a year, we were running twice as many simulations as we otherwise would have done. But it built up this huge library of back-to-backs. And then you can just look at it. Are these trends the same? The absolutes might be different. And does the post-processing look correct and the same? And we're at the point where first you go, okay, now we just run the baselines in Fluent and then we do all our development in OpenFOAM and then we'll recheck a baseline and things like that to build up the trust. Then when we set up Tillotson, we made the decision to not wholesale, but for 90% of our stuff, we switched to OpenFOAM. And then the trickier physics, we then used Forstill, but then gradually over a year or 2, we migrated the more complex workflows into OpenFOAM and eventually pitched to Fluent licenses. So I think it's an interesting process to go through, but getting over the reluctance and the inertia was a challenge for certainly.
Yeah. I've started same concept that I've encountered. I say engineers are very rational until you start talking CFD codes. And it seems to go out the window, which I get. People have preference. I have an emotional attachment to those experiences that you have learning working with your first code, whatever it was. Or anyway, so understandable, but still makes me chuckle from time to time. It just, one anecdote. So one of my supervisors had a preference for one code, and the company had two options, and I was more familiar with another option. And so I chose to tackle the problem with that option and just wouldn't even believe the results, couldn't believe it. And then we got a different problem and he couldn't even get an answer from his solver. I didn't dive into it, but he couldn't even get a result. And so it was just a funny interaction. And that's where I started. That's what was my first experience of, wow, this is a real thing, that it's not just, yeah,
Yeah,
the
know what
cost.
you know what you kind of feel frustrated by change and things like that. Someone we know very well in their team, which commercial code they use, but he was trying to push OpenFOAM, and they're like, no, it's not ready, it's not ready, it's not ready. And then they needed to make some cuts. I can either sack 3 of you, or we can switch to OpenFOAM and save the license costs. And it was like, yeah, well, it's ready. And sometimes it needs something like that to really make the change.
Yeah, that's great. Great story, and great for them too. It's so Bramble's website, and we've touched on this, but the website mentions Bramble allows engineers to create and run simulations quickly and manage large data sets. So how does Bramble do this differently than maybe another software would? Or what's really unique? And I get that there's some created by the engineers for the engineers here, right? This is something you guys are using and you really understand your processes, but maybe if you could expound on that as well.
Yeah, I think I put that in context. So we've done quite a bit of work with, or we work with the FIA, so the governing body of World Motorsport and Formula One as it was. They, in the run up to the release of the new technical regulations, it was 2021 or 2022 when it came out, but the year up to that, they had 3 aerodynamicists and they ran 3,000 simulations. That's 1 year, 3 engineers, 3,000 simulations. And these are full car F1 level models. And you can't do that unless you've got a process that is incredibly slick and very easy to use. And that's sort of what we try and achieve. We've got a bit of a buzzword, but it's making the hard things easy. It's not like we're not make it easy to use, but not by dumbing it down. We want to be able to run the best simulations with high quality simulations, certainly and easy. And when you're generating all these simulations, you can't just look at them one at a time. You've got to have a process or something in place that lets you handle the kind of large amount of data that this generates. Bramble's results here, it isn't about looking at that one simulation that you've just run. We have a forces view where you tabulate every run, a spreadsheet, but from there you can click on any of those runs and you can immediately load up the post-processing for it. Yeah, it gives you access to all that data set. And because it's all done, I guess you do it like at a company level. So every engineer has this kind of shared space where they can all see each other's results and simulations. And it means that someone leaves, you haven't lost all their data. It's not siloed away or hidden away in some report 5 years ago. So the data's there in perpetuity. You can just click on the project and view it. All the reports and results are there as well. If you want to click on their comments on the run, that all gets saved. So I guess what we look at is not simulation A and simulation B. It's how can we manage this whole process and manage this whole data set so everybody can have visibility of it and feel involved in the process. I think one part of it comes from being consultants. If someone pays us $5,000 for a study, it's not a particularly rewarding experience for them if just at the end we hand over a report of, this is what happened or this is how we made it better. Everyone gets a login to the platform. It's shared between our engineers and the customer. So they can see the data, see the runs as they're being created, where they are in the queue and as the forces appear. Which is a bit of a culture change, I think. We have customers who'd be looking at the results over breakfast before our engineers had even got in the office. And so you have to get your heads around of freeing up this data, but it makes a much more collaborative experience. And I think, it's rewarding for all the parties.
Yeah, that's awesome. So I want to dive deeper here. You use this phrase, make the hard things easy, but not dumbing it down. And I think that's this irony I feel like we're at, where because there's so much compute, like things are getting easier and easier, right? For maybe a younger engineer to do CFD, because tools that we have and like tools like Bramble that make it easier to do these things, but how have you balanced that how have you been able to do that without dumbing it down? Because I feel like there's this mind in this is maybe for people who think that, I just feel like there's a real stigma around how people start learning CFD and what's the best way to do it, right? And the easiness of a tool, in my mind, should not be against the quality of what you're learning, right? I can still have an easy tool, but it's effective and I'm not dumbing anything down, right? Does that make sense? That idea of,
Yeah, I think the part of it is the kind of resource that you need access to if you're going to be doing it yourself, right? And there's the various barriers. That might be knowledge. What mesh should I use? What solver setting should it be? Or what kind of compute? If you want to do some big models, you can't do it on your laptop. You need access to HPC, and that in itself has a whole load of knowledge barriers and things like that. And even just for a team that, or someone that they might be technical experts of decent lots of cycling. So you've got a team, they know everything about cycling, and they probably know a lot about aerodynamics. They haven't not got the resource to do the CFD and even learn how to do the CFD. And I guess what we do is at Bramble, we've done CFD for a number of years, and so we bake in our best practice. So if you came to me and you wanted to do a car, we would populate Bramble with the mesh recipe, the solver settings that we think are best for a car. Now, those are all editable. So you could then, actually, I want to find up the mesh here and change these things. But in order to get you over that barrier, that kind of initial knowledge, we say, this is how we do it. So you can end up creating very complex workflows, but because we have all that knowledge and stuff that we can put into it, it really, gets people running very quickly. I can train someone up in Bramble because it's so heavily automated. In a couple of hours, this is how it works. And all you need to worry about is actually looking at the results. You can upload some STL and look at post-processing reports and never get into the CFD. And ultimately, a lot of what Bramble does now is OpenFOAM, and which in itself has a horrifically steep learning curve, or it traditionally has anyway. But that's entirely abstracted. So we get it Bramble to create all those kind of input scripts and things like that it needs. But that's one of the powers of OpenFOAM, is that you have hands-on access to the data and you can automate everything.
Yeah, thank you for expanding more on that. Another thing I'd like to dive in more to is this idea of, I've worked in consulting, not always CFD consulting, but consulting for past almost 10 years, various levels. And one of the things I've observed is a hesitancy of consultants to share maybe their recipe, right? And it sounds like this is what this platform has done and allowed you to do. And you mentioned there's been a lot of benefit that's come out of that, and that collaboration and just fully opening up, hey, they can see everything, right? You mentioned that the engineers looking at the results over breakfast before you guys have gotten in.
Yeah.
And I believe one thing here, Sue. So I believe that to do the best client service you can as a consultant, you're better off when both parties have more information that's relevant to the problem you're solving. And I've seen some hesitancy in consulting generally. Now, I'm not saying this is specific to CFD, but just maybe a lack of willing to be vulnerable about learning new things, or maybe even mistakes along the way. And
absolutely. It's as I was saying, it is a scary thing. Back when Tolson was quite new, we started using OpenFOAM, and we developed a lot of knowledge in how to do it. And so Rob Lewis, the big boss of all of Tolson, he said we should be offering training and support to give our codes and to customers and things like that. And I think everyone's reaction was, whoa, we just spend years developing this stuff. We can't just give it away.
Yeah.
But he was right. What it actually turned into is free shared methods. And then you're stuck on a problem, or you're really busy and you need some extra resource you're going to turn to. And that'll be the person that does the same thing as you. And that's how it worked out. We support a number of customers who do their own CFD, not through Bramble, as OpenFOAM users. And they'll come to us like, we need help building this model, or half our team's off sick. Can we have some of your resource? And it builds up like a real community and kind of a trust. But yeah, and it is a nerve-wracking thing to do, and I can totally understand why you wouldn't want to do it. But it's worked very well for us in terms of building relationships and things like that.
Yeah, another thing I want to touch on, and if you're able to share, great. If not, totally understand. But how has it changed your a second concept here, maybe of business and just general business, that the way I see it and my reading and learning is the more trust you have, the easier the transaction is, right? That both parties, there's an entire book written about just the speed of trust in business. And as you develop more and more trust, the working relationship gets better, and it's actually mutually beneficial. So both parties, it's everything about it gets better when the trust increases between both parties that are doing business together. And the example is, I think Warren Buffett was acquiring a company, and instead of having any auditing or all of the amount that goes into the financial stuff, they just did a handshake deal and they trusted each other. Obviously, it's extreme, like we're talking way extreme, hundreds of millions of dollars. But I love the principle there that he trusted that the CEO, everything was going to be how it should be when ownership was taken over. And so I feel like that idea is relevant, though, to this, that it benefits both parties from a business perspective, too. Like, it's not just, it's nice relationships and maybe workflows, but like fundamentally from bottom line and actually producing value as a company, there's a monetary benefit when trust between parties is increased. And so I just didn't know if you could speak to that.
Yeah, I in terms of just the simple idea of maintaining renewals and things like that, if you where you're going to go, if you get your support from company A and they've been open and honest with you, and you just right, should we go with company B? They might be a bit cheaper. But no, the grass isn't always greener on the other side, is it? It's got to be, I think just from a satisfaction or a willingness to people to stay with you, it just makes a massive difference.
Yeah. I think the reason I wanted to bring that up is I feel like there's so many times where you come out of university thinking that the most technical or the best or the most complex solution will always win in the market. And it's really eye-opening to get into the world and see how things go about and how much trust does play a role, especially in simulation and the things we're trying to do. So
I think for us, it's when we say this is our best practice, this is what we do, and we generally mean it. This is the same kind of simulation. Like, if this was our project, this is what we would do, and we've been doing this 20 years, and I think that has built that in itself adds a lot of weight to what we're saying and things.
Yeah, thank you. Sorry, just a little tangent. So Bramble was in development for over 5 years before being spun off as a separate company, right? Why the spinoff? I'm just really curious why this separation.
Yeah, so it started out as a CFD consultancy, and over the years it's grown and diversified. We do all sorts of things related to external aerodynamics. So we've got a sports science facility, so a cycling wind tunnel and test machines, sports clothing business. If you've not checked it out, there's Catesby Tunnel, just half a mile up the road from me, which is a 3-kilometre disused Victorian railway, which we build a road through. And so you've got like a straight line test facility in controlled conditions. And we've got 2 different types of consultancy. We've got the car business and then the tricky physics stuff. But that's a lot of different things. So if something comes to Tulsa, it's a very mixed message. And so separating these companies out into the different things that we do makes a lot of sense. It makes it very much easier for someone to say, oh, I will do CFD myself. And so we can point to Bramble, or I need help developing something for OpenFOAM, or we can send them to the Tulsa CFD guys. It just clarifies things a lot compared to what we were doing. We're in a collection of businesses, really. So
That's awesome. Who do you think can benefit the most from Bramble? I know you talked about there's various ways you can use it, but in your mind, who do you think gets the most value out of Bramble?
We have 2 types of user I would consider. So there are teams of CFD engineers who I think face a lot of the challenges that we are facing when we created Bramble. They're doing lots of simulations, or they've got engineers that come and go and things like that, and they need to That's all those crashes that we talked about. And then I think the other half are people who want to use CFD, they need to use CFD. And they, yeah, I think traditionally there's like kind of individuals or small teams, they're not served well by the traditional CFD market, because you got licenses you have to pay for like annually, and you need compute and X, Y. I think there's loads of options now that in the last few years that have come online to serve these people brilliant. And we have the second type of user who, I guess more often they would have used a consultant. They would have paid someone to do their CFD for them, but actually they want to bring this knowledge in-house and the ability to do this. But for them, it's very much it's something they might pick up and put down again. So they might use it for 3 months and then not touch it for another year. So we don't have a license fee, it's pay as you go. And we use that model so that we can serve customers who, have a very trans need for CFD. Yeah.
So clarification, does that pay as you go, does that include access to your platform, which comes with compute? Or are they having to provide the compute themselves?
It's all through the platform. So it's essentially you pre-purchase core hours, and then when your simulation completes, we deduct those core hours. And if you want to buy enough to do one run, you buy enough to do one run, or if you want to do a whole project, you can buy more. It's very flexible for that regard.
Yeah, but just consumption based, whatever you're using is what you pay for.
Which I think is very outside of the world of CFD or engineering. It's a norm. It's a very normal thing to do now. So we're very comfortable with opting it that way.
Yeah, that's awesome. What do you think are some of the misconceptions that people have around Bramble, though?
I guess, firstly, it's not a CFD code in of itself. Bramble's not a CFD solver. It creates CFD cases, but it's there to manage this whole kind of life cycle. And that's one of the expressions. Now, for a lot of people, that's what it is. It is the CFD for them. It wasn't really designed that way. It was made to be something to make our whole day easier, more efficient, and things like that. We also, because of TileSim and our history, we're very with OpenFOAM. It's just what we use. But when we sat down to create Bramble, we consciously made the decision that not everyone wants to use OpenFOAM, and so we built in the flexibility into it to integrate other CFD codes. So if we want to, as long as that code can be scripted, it can be driven automatically. We're looking at integrating different solvers. So we've added a fast acoustic solver, which the guys at Xenotech created. So you can now create those simulations instead of just OpenFOAM models. And because, whether you are using a commercial package or an open source package or whatever, the challenges that we face are still valid. We're wanting to do that. Then we also do a lot of our history is within high-end CFD, big models, big cars, all this kind of stuff. But it is designed to be accessible. So if you are doing just 2 runs, you don't need to hand over £100,000 of credit to get stuck in. You try and be a lot more flexible than that.
Yeah. So what do you know now about building Bramble? And like you said, you started CFD, right? And then you got more and more into the code as your career's gone on and programming. What do you know now about building a software company, basically, right? That's what Bramble is. You're selling the software that you wish you would have known earlier, kind of things that may have helped you out earlier in your career.
Yeah, I think, first of all, everyone should learn a bit of programming. I think I learned Fortran 77 at university, or a bit of MATLAB or something like that. When I realized that you can do with a bit of Python scripting. Everyone should have a bit of coding in the toolbox. In terms of kind of training Bramble and things like that, it was interesting to listen to your last podcast, and exactly the same sentiment is that there's so much that we can do. It's like you can read the mind and go, wouldn't it be brilliant if we got Bramble to do this and things like that. And it's how do you focus that resource? Because we've got a finite amount of time, we finite developer hours. So where do we focus it? And so what we did is, there's an adage. If you made dog food and you served dog food in your own restaurant, in your cafeteria, so you had to eat your own dog food, you would make the best dog food in the planet, right? And that's our approach to developing Bramble. We kind of, there was like we saw that needs to be the future. And we got like an alpha version. It could do about half the things that it needed to do. And Rob, he was like, told our safety, the consultancy team, you're using Bramble now. And they're like, no, but it'll slow us down. It's not ready yet, and things like that. And he goes, no, you're using Bramble, and then you're going to beat Isaac up every day till he makes it good enough for you. And yeah, that's exactly what we did. But it let us create something that works really well. It does it's very good for what the engineers want, because we got our engineers using it. I think if you're developing software and you're developing it in a bubble, you're doing what you think people want, which could take you a long way. Actually getting people using it, getting that feedback, using it yourself for real, that's been a massive help for us. It's really let us create something that works well, I think.
Yeah, that's awesome. Is there an anecdote or an example that you could share of maybe something that wasn't obvious or intuitive for you from the development side that came to you as feedback from the team on, hey, this is something you guys need. Why isn't this here yet?
Ooh, that's a good one. I think there's a lot of this. We do a lot around automated checking and catching errors and things like that. And it's people make mistakes. And in CFD, it's really easy. You type in the wrong number or a negative, or it should have been a positive. And worst of all are those mistakes that you could run a model and you'd never even know you've got something wrong. It might look valid. And so you'll decide what your conclusions are could be entirely wrong because you even made a setup error. And so, and especially with something where the process is really automated, it's very easy just to fire things off. And so we've had a lot of feedback and a lot of suggestions of how can we capture all these errors, what things can we do, and whether that's as simple as you've got a car and you've got a radiator in the model, but your infrastructure is missing it. And Bramble will just say, yeah, you're missing this radiator. Or we generate a load of images that it might be a completely valid model, but you've left a piece of geometry off. So how can we, can you create us a picture that shows the difference between model A and model B? Oh yeah, we can do that. And it's those, help us that, especially if you generate lots of runs, you try and do it very quickly. That kind of error catching stuff. A lot of the post-processing stuff as well, different types of images or, plots, or you want to plot a force distribution and you need to stick a picture of a car behind it. Things like this are but painful to do if you're trying to put it into a report. Wouldn't be great if you could just do that in Bramble. Okay, we can take a look at that and things like that. You don't really know where people's pain points are. And so getting that feedback of people saying, I really hate having to copy and paste images into a report. What can we do about that? Things like that. So.
Yeah. So does this just spit out a LaTeX type report or?
So go.
I was just going to say, you mentioned early on, consultant, the last thing like customer wants is just a report for SIMs. And so now they can see everything, but at the same time, there's probably still a need for a report to be generated on a specific thing too.
This is something we've done a few different ways as, we've kind of received feedback and things like that. Some of them worked, some of them haven't. So we have a more traditional reporting function. So create a title, insert a force table and things like that, which is used occasionally, but more often used actually. So effectively the results use like a spreadsheet. And then you can just have a comments section. So you can just open a little text box, write in your analysis and close it, or you can take a screenshot, draw on it, upload it back in, and it saves it as an image that people can view. So I think there always is going to be reports and things like that, but you need it less than you think. When everyone's got the data, when anyone can log in and see it, access to it, can see it, you don't need that formal report. You can just have a run that says this is what's happened, and people can understand that and draw the conclusions from it.
That's cool. Yeah, really awesome insights to hear about the process and how it's being used. One more question on the speed up, right? As I'm hearing more about this, I have a much better understanding now. So I'm really curious, how much time, like in terms of hours, do you feel like Bramble has saved you? Like I'm thinking this is a whole, there's this idea of products to succeed. It's like the whole product solution, right? You're not just improving one piece of the workflow. You took the approach of the entire workflow of a CFD engineer from pre to post processing. So how much time do you feel like
You could count it in like days, months, years. It depends on the kind of stuff you do, the simulations you're doing. So where Brambles really excels is when you're doing lots of simulations of very similar types. You're doing lots of cars, or you're doing lots of whatever it is, and that's where it really comes into its own. Yeah, I mean, I mentioned before about changing a ride height on the vehicle. You probably spend the morning doing that, or a day or something. And in Bramble, it's 2 seconds to type in a new setting. He's like following car stuff. That's to get your heads around. So following car, we do a car in corner. So a car's a curved flow field for a corner. So through a corner, you need to model a curved flow field. And so if you've got a lead car or a car that's around that corner, your role steer, you try to move things in a non-Cartesian rotation, non-Cartesian axis, updating complex vectors and stuff. It's a week-long process to do that, set up that model, and you can do it in a few seconds. You just specify a corner radius and stuff. Getting the code to do that was an exciting challenge, but some things it can do very quickly. But a new simulation off a existing baseline, you can create them in seconds. You just upload your geometry and press copy run. Add my new geometry and go. So I think the kind of more intangible one, or something we never really looked at, is it's the analysis. If you think you're trying to load 2 things into Parity or whatever, and you've got to find that data on disk and load it in, you're spending 5-10 minutes just to get to your data, and it's designed to just be there waiting for you. You add that up over a team of engineers over a year, you get a lot of extra and should bang your buck, I think.
Yeah, that's amazing. One other question on this. What do you think was one of the most difficult technical implementations of Bramble that you did? Maybe like the cornering one or...
Yeah. The cornering one was this guy. If you ever seen that meme as the guy, he's got the whiteboard and he's drawing all over it, getting stressed, trying to explain something. And it was like that. I was sat down with my developers. This is what we're trying to do. You had like a whiteboard, put sticky back plastic all over a wall, drew out what we were actually trying to do. And because if you think you create an offset, you've got all the mesh settings get duplicated and the weight blocks get moved and all this kind of stuff. It's like a big long checkbox of things you need to do. Yeah, I mean that was a pretty complex one. But we have our own compute as well, but people have their own compute, and so Bramble can link. You can palm cases off to different places, so you could run it on Amazon and on someone else's compute. And we did a whole load of work with Amazon they wanted to use data centers all around the world. And so, Bramble's software, Bramble, where's the most capacity? Where can I palm this job off to? And then you're orchestrating runs, across data centers, across the Northern Hemisphere. And And when it all comes together, that's the thing I love about programming. You can bang your head against the keyboard and then it suddenly works. You're like, that is good. Yeah, it's an incredibly satisfying thing. But it's like they were the FRA guys. They're a brilliant bunch, and doing the stuff with them has been incredibly rewarding. They certainly pushed us to make Bramble into what it is now, and that achieving it, I think, has been really good.
Sorry, who was it that has pushed you?
The FRA, so the Formula One.
Okay.
Friday, they were. They're like, we needed to do this because they're essentially they're not in competition with the teams, but they have to develop a car that is good enough for Formula One. They're a very small team, so they needed the ability to do lots of simulations.
Yeah. So. And you said they were doing 3,000 a year between the 3 of them, right?
Yeah, that was it. So one year, 3 engineers, 3,000 simulations or thereabouts.
Okay.
And not just running the simulations, just analysing the data and actually making this quiet thing. But that was Amazon, the kind of compute. We couldn't have done that. We couldn't have supported that with our kind of in-house computes. I think the rise of cloud suppliers and things like that has been fantastic for kind of our industry. Suddenly you've got always got access to the latest hardware and the latest tools and things.
Yeah. Well, something that I have become more aware of since I'm starting doing this podcast is F1. Like none of my friends growing up, it wasn't a thing in my circles growing up here in the US. And I have slowly had my eyes opened to just the bigness of how big it is throughout the world. And so it's been really interesting because it was not a part of my life growing up at all.
Yeah, I
Like,
would say it's cracking America has always been one of the things, isn't it? You've got such a rich motorsport heritage of your own series and stuff. It's always going to be a challenge for them, I think.
yeah, it's definitely been interesting. So I want to touch on this more because for me, I still don't even know. I could guess, but like, what cell count are you looking at on when you think of a full car F1 car?
So yeah, a full cast for us end up being around 100, 150 million cells. That's the sort of what we look at. I know teams that run a lot. So some of the F1s, I think there's perhaps two flavors. Some teams run much bigger models, share them because they have resource restrictions in Formula One. And there are teams run perhaps more like Redig, but then run more simulations. So, yeah, there's perhaps a couple of different schools of thought, but yeah, our stuff ends up being around
100 to
150
150.
million cells.
Yeah, really interesting. So wrapping up here, what trends are you seeing in simulation and what gets you excited about where we're headed?
Yeah, I think we are at quite an exciting point, guys, at the moment. So 10 years ago, we ran simulations overnight. 2 years ago, we were running simulations overnight and got stuff running at the moment. They have overnight turnarounds. And what's changed? Computers gone up massively over that period. But what we've been doing, or people, CFD engineers been doing, is adding more fidelity to their models. So it'd be 10 million to 150 million cells, and then 2 years ago, it might have been 90% steady state runs, but now it's 90% transient DES simulations that we see. And so as we've gotten all this extra compute, people have been adding in lots more physics. And now I think we're on a bit of a cusp now. We've got the rise of GPU code, which that's some of the speed I actually see with that stuff is mind-boggling. And then I wonder what we're seeing. Will people go for, I'm going to carry on running my random simulations, but I'm going to do it in half an hour or 10 minutes, whatever it might be? Or are they actually, now I can do LES simulations because I can throw more physics at it because I've got more compute. So yeah, it'd be quite interesting to see how that plays out.
Yeah.
But yeah, GPUs, that's quite a game changer. I think maybe 6 months ago, I was wondering, what does that spell for OpenFOAM? Because I've not seen a good OpenFOAM port for GPU. It's too much on the CPU. It hasn't sped up a lot. But then we started using some of the ARM type architectures. So we've done a lot with Amazon and their Graviton stuff and seen whole workloads shift literally overnight from using the AMD Intel architecture onto ARM. And it's so cheap that you can throw loads of cores at it. So actually you've got confirmed jobs, not GPU accelerated, but running in per hours on loads of ARM chips. So yeah, I think if there wasn't AI, all these GPUs would be a lot cheaper and we'd be able to use them for CFD more. But yeah, obviously then there are reasons, you couldn't answer a question like that and not mention AI and ML. I think machine learning stuff. I think that's going to be really interesting to see how that plays out. I see some really exciting things going on in terms of live update. You're pulling a geometry around and the AI is giving you a live prediction of the solution, stuff like that. It could be really exciting where that leads.
Yeah. One of the things I see, and I think it was desktop engineering, was they'd asked me if I'd seen or used a code that has like a voice GUI. I don't even know what you'd call that, but instead of clicking, like just a voice, like telling it, hey, I want this model. And so that was one thing that I think has a lot more maybe direct applicability right now, right? Like some of this stuff we're still working through on the physics side, but like the interaction, is that something?
Yeah, that's a really interesting point, actually. We, a few years ago now, 2 or 3 years ago, we had some professors from a university came and visited us, wanted to look at machine learning. And they were like, how can we use machine learning or AI to improve the process? What can we do? And I think the answer they wanted was like, it'd be great if you could solve the solution so we didn't have to do the CFD. But we all sat there and went, it's a real painful preparing models for meshing. To bash CAD ready for CFD, that's really hard. If you can get the AI to do that for us. And it was like, that looking like that wasn't the answer we were expecting. But I think there's and rightly, there's a lot of focus on the physics and
Sure.
that stuff. But yeah, I think there's, I guess one of the barriers with CFD still is the aerodynamics knowledge. Can we we generate all these images and movies when they log in, can it prompt you to say, Yeah, we think your wing stored. Judging by this flow field, we think the wing stored. Have a look at it and things like that. I think, yeah, there's this again. By looking at the whole process, everything that we do with CFD, and as engineers, where can AI slot into it? Your CFD Copilot, like the coders of people who's encoding have got, is you've named that part wrong just as you're uploading a bit of geometry. No, it's not really, it's front wheel or something.
Yeah. That's cool. I know I always, every time, leave enlightened, and you've shared a bunch with us. So I really appreciate your willingness to share. And if people who've been listening are like, oh, I want to get a hold of Bramble, what are their next steps?
Oh yeah, get on the website, have a reround of it. So with bramblecfd.com, and there's an email or a form off the back of that, and we can have a chat and see how it might work for you. So
okay,
it's designed to be used no matter your skill level, really.
Awesome. Thank you again, Ivor. This has been great.
Yeah,
and really
it's been good to talk, Keith. It's been really good.
Thank you for listening. Really, thank you. Did something about this episode stand out to you? If so, please go ahead and share it with others on LinkedIn or other social media so they can find this as well. See you next time.